Hi friends, today we are discussing about projectile motion. First of all, you should be familiar with what's a projectile. Anyone which we had thrown and are in flight are called projectile. For example, in the case of javelin throw, we had thrown that javelin and it will fall down in this way. Okay, so that javelin is the projectile. So the motion of the projectile, it is known as projectile motion. Okay, so first of all I am fixing the frame. This is our frame. And do you know what's this projectile motion, what kind of motion it is? Yes, it is two-dimensional motion. So this one, this is origin, and this is the velocity vector, the velocity with which we are projecting the object. So we know that the shape of that projectile motion, it will be parabolic. Okay, yes. So this is a maximum height. In this video, we are going to discuss what is this time of flight, capital T. That is nothing but the time that a projectile takes from origin to the ground. Time taken to reach the ground from its starting position, that is time of flight. And this time, the time from origin to this point P, it is called time at maximum height. Okay, so the since this projectile motion, the graph of the trajectory of the projectile motion is parabolic. It's an inverted parabola. So it is, we know that this parabola is symmetric. So the time taken from here to here, O to P, it will be equal to the time from P to B. Okay, so before that we need certain things. That is, this is the velocity vector. I am writing it as v0, and the angle between the ground and velocity vector to be theta. So we had already learned about the how to resolve vectors. So the vector near to this theta, that is x component, it is equal to v0 cos theta, and the vector here far from the theta, that is equal to v0 sin theta, far component. How to derive it, that we had discussed earlier. So then we have the equation S equal to equation, Newton's equation of motion, S equal to ut plus half at square. Then we have to find y. This is y. This y in this equation first. That is, in place of u we have v0 cos theta. v0 cos theta into t. Okay. Then in the upward motion, the we have acceleration due to gravity. According to the Cartesian sign convention, it is what, a0 equal to minus g. Okay, this yes, a0 equal to minus g, and that is equal to minus half g t square. Okay, minus half gt square. Yes, so here when we take it upward, we are taking it as negative, negative g. Acceleration, that's equal to negative g. So we have y equal to u sin theta, sorry, v sin theta t minus half gt square. V or v0 we took. Then y equal to, so we have to differentiate this, that is vy, we will get dy by dt. That is velocity, distance by time velocity. Y is a distance, so d by dt of, we don't say dy by dt, we call it, it's d by dt of y, don't call it dy by dt. Then this is equal to v0 sin theta minus half into this differential of t square, that is 2t. So we get gt. And at the topmost point, so here at the topmost point, the vy will be 0. if we are throwing a ball with a velocity, then if it is coming back at the topmost point, it will come back. So that is there the velocity is 0. Applying it, 0 equal to v0 sine theta minus gt. It gives that v0 sine theta equal to gt, and so t equal to v0 sine theta divided by g. Okay, this is time for maximum height. We know already this parabola is symmetric. So Tm equal to V0 sine theta divided by G, double that. It is double that is time of flight, 2V0 sine theta divided by G. We have to do numerous problems based on this time of maximum height and the time of flight. It is called time of flight, that we will discuss later. So we can meet in other class. Okay, thank you.